which are flips. We'll look at rotations as well as dilations. So reflection, this is when a figure is flipped or reflected about a mirror line, which can be abbreviated as ML. And it also then becomes the line of symmetry between these two figures. So here is the mirror line in this diagram. Here's the mirror line in this diagram. And another way to remember if it's a reflection is if you were to fold this page or even imagine it being folded, they would lay on top of each other, the two figures, if you fold it right at that mirror line. All right, so this is the example in our module, and it is also incorrect in the module, so that is why we do have to go over this one in the module, just to show you the correct one. I've put it in orange here again, so I've put X's through the ones in the modules that were done incorrectly. So if we look at figure or triangle ABC, triangle ABC, point A is at 2, 6, which is very clear here. It's at 2, 6. They've put 2, 5. For point B, it's clearly at -3, 3, and they've put -2, 3. So clearly wrong there. And then 4, 1, C is correct. So I've put the new points up here. All right, so we're flipping this triangle ABC about the x-axis. Here's our x-axis. So the way you've learned previously in previous classes is when you're flipping, you just count down to that mirror line, and your new point would also be at that new point. All right, so when we look at our points here, point A, which is at 2, 6, the new point becomes 2, -6. When we look at point B, which was at -3, 3, the new point becomes -3, -3, and point C, which is 4, -1, becomes, 4, 1, which is the original point, it becomes 4, -1. So it should be right here, 4, -1. And so what you'll notice as a pattern here is that the x value stayed the same. So 2, 2 stayed the same, -3, -3 stayed the same, 4 and 4 stayed the same, but the y value became opposite. So that's what you'll notice when we're flipping about the x-axis. And then here when you're flipping about the y-axis, the y value stays the same, the x value becomes opposite. So point A, the original figure is here at 5, 6. The new point is -5, 6. So the y value stayed the same. Point B is at 2, 3. The new point is at -2, -3. All right, so again, the y value stays the same, 3 and 3. And same thing for point C, -3, -3 stayed the same. The x value becomes the opposite. Okay, so then we're going to look at rotations. So rotations this is when a figure is turned about a specific point, which is called the turn center. So when a figure is turned 90 degrees clockwise, CW represents clockwise, it's the same thing as turning 270 degrees counterclockwise. All right, so if we look at this figure here to just show that as an example, clockwise, 90 degrees, rotation would be here. If we went counterclockwise, 270 degrees, 1, 2, 3, we would still end up in the same position. So a figure that's turned 90 degrees clockwise, it's the same as turning 270 degrees counterclockwise. A figure that's turned 180 degrees clockwise or counterclockwise would be the exact same. A figure that's turned 270 degrees clockwise is the same thing as 90 degrees counterclockwise. All right, so just keep in mind CW is clockwise, CCW is counterclockwise. So there's rules for rotations, and I've put them here. So if it's a 90-degree clockwise rotation, xy becomes y negative x. 90 degrees counterclockwise rotation, xy becomes negative yx, and so on. So if we look at this figure here, our original figure here is triangle ABC. Point A, point B, point C are listed here. Those are the original points. So when we do a 90-degree counterclockwise turn, the new figure will be right here. So A prime, B prime, C prime. And it's the same thing as a 270 degrees clockwise rotation. So if we had gone, sorry, did I say clockwise? I meant counterclockwise. So it's the same thing as a 270 degree counterclockwise rotation. So if we went this way, 1, 2, 3, it would still end up here. All right, so the rule for that is xy, it becomes y negative x. So our original point was 1, 2. It changes now to y negative x. So the new point is 2 and negative 1. From 1, 2, it becomes 2, negative 1. And if we do a 180 degree clockwise or 180 degrees counterclockwise, it doesn't matter because it's the same image, we end up with this figure here, the A double prime, B double prime, C double prime. And the rule for that is xy becomes negative x, negative y. So we just changed the signs. So it was, the original point was 1, 2. The new point is negative 1, negative 2. The original point was 5, 3. The new point becomes negative 5, negative 3. 3, 6 becomes negative 3, negative 6. And the last one is if it's a 270 degrees clockwise or 90 degrees counterclockwise, it would make this figure here. So the rule for that one is this one here, xy, it becomes negative yx. All right, so original point was 1, 2. It now becomes negative y, so negative 2, and then x, which is still 1. 0.53 now becomes negative 3, 5, and then 0.36 becomes negative 6 and 3. So just looking at some other examples here. Here it's a 90-degree clockwise rotation. So our original point, which is xy, the new points become y negative 6. Okay, so it's shown here. So the original point was negative 4, 7. The new point becomes 7, 4. Negative 6, 1 becomes 1, 6. Negative 2, 1 becomes 1, 2. All right, so shown as this is a 90-degree clockwise rotation. Here we have 180 degrees clockwise, or it could be 180 degrees counterclockwise rotation. So the xy becomes negative x, negative y. So 2, 7, it becomes negative 2, negative 7. 0.21 becomes negative 2, negative 1, and 0.61 becomes negative 6, negative 1. We have a 90 degrees counterclockwise rotation. So the rule for that was xy becomes a negative yx. So we're going counterclockwise. So here's the original figure, counterclockwise to here. This is the new figure. So we can see what's happened to our points. They've gone from xy to negative yx. All right, so negative 8, negative 2 becomes positive 2, negative 8. And this is a quadrilateral, so we have 4 points. All right, and this last one, we're given points and we have to figure out what's happening. So if you just look at the points, negative 8, 3 became 8, negative 3. Negative 5, 5 became 5, negative 5. Negative 2, 3 became positive 2, negative 3. And negative 5, negative 3 became 5, 3. So this has to be a 180-degree rotation because the values of x and y don't switch, just their sign is changing. Okay, nothing switched, just their signs changed, so therefore it has to be a 180-degree rotation. So looking at dilations, which are enlargements and reductions of a figure. So when we dilate a figure, the object, it changes size, but it will still maintain its shape and is always similar to the original figure. So similar meaning the size will change, but the angles always stay the same. So all the angles are the same. The sides either become larger or smaller in accordance to a specific ratio. So here we have triangle ABC. So the little one inside triangle ABC, and we have the following points for it. And we're drawing an enlargement using this ratio. So xy, it becomes 2x, 2y. So it means the triangle is doubling in size. So since it's doubling in size, all you have to do is multiply the points. So point A was at -4, -2. You're going to double it. So -4 times 2, that gives us -8 for the x value. -2 times 2, that gives me -4 for the new y value. And you'll do that for each point, and you can get your new figure.